All right, welcome to your review of complex numbers, right? So we're going to go through all of the problems on the review worksheet, right? And we're going to start off with adding them together. And in the directions for everything on this worksheet, there's no directions for each problem. They're all just combine like terms, right? So we're trying to combine like terms here, right? So let's start off with the first one and see what happens, right? So in this case, I have two complex numbers, right? So I'm going to start off with this one that's got an 11, this one's got a 2. I'm going to combine those with an addition sign, so that's going to make that a 13. And then negative 7 plus negative 5 would make negative 12, negative 12i, right? Notice how I'm not changing this and making it I squared, right? If you remember that exponents like squared are a multiplication thing, so when we're adding them together, there's no change. This is my final answer. It's literally just combined like terms, in this case by adding. Okay. Problem number 2, same thing, except there is a subtraction sign in between them, so we have to be a little bit more careful, right? So I'm going to say negative 6 minus positive 1, and that's negative 7, right? And then here's where we have to be careful, and I'm going to actually write this off to the side. This one says 10i, okay? There's a minus sign, okay? And then negative 2i. So when I'm doing this one, it's really going to be like a plus. Okay. So when you're subtracting in particular, be careful. This one's going to be plus 12i. Okay. So negative 7 plus 12i is the final answer. Okay. That's all you have to do for adding and subtracting. Okay. So here's another subtraction just for practice. Right. This one says negative 3 minus 1. Well, that's negative 4. And then right here I have 8i minus sign 8i. 8 minus 8, 0. That cancels. All that's left is the negative 4. Okay. Well, moving on, number 4, multiplication. So this one's going to be a distribute, right? So I'm going to say negative 5i times negative 2. Well, that's positive 10i. Negative 5i times negative I is going to be positive because the negatives cancel. And then 5i squared. Okay, and then here's the biggest, the first time I'll say this, but not the last time, right? One of the biggest points of the whole chapter is that I squared is going to be negative 1. So I can change this. This is really going to say 10i plus 5 times negative 1, which this is really negative 5. Okay, and if you notice, whenever we write our complex numbers, I goes second, the number without I, which we call the real number, that goes first. See? So when I say this is negative 5, I'm going to write that first, and then I'm going to put positive 10i plus 10i. Okay, so this would be my final answer. Okay, so you have to distribute. Anytime you see I squared or any I with an exponent, which we'll see a little later, that's going to become negative 1. Okay, and then just kind of move things around. Okay, problem number 5. This is also a distribute, but because this is a binomial, we're going to distribute twice. So I'm going to say 7 times 4, that's 28. Okay, 7 times 3i is 21i. Okay, and then I'm going to do another distribute, which is I times 4. Well, that's 4i. And I times 3i, which now I am going to do I squared, right? Because I times I does give you an exponent. I plus I does not, okay? So now that I've distributed, the goal here is to combine like terms. I see 21i and 4i, so that's just going to be 25i. And again, I'll point it out, I'm not doing I squared because I just added those together, okay? And I'm seeing right here, again, an I squared equals negative 1. So this is really 3 times negative 1, which is minus 3, right? And now that I've made that a minus 3, there's no more I attached to this. I can say 28 minus 3. Notice I'm not using this plus sign. I'm using the minus sign before the 3. 28 minus 3 is 25, okay, plus 25i. That's my final answer. Okay, I can't combine something with an I and something without an I. That's as good as I can go. Okay. Problem number 6, same thing. Right, just watch your negatives. I have negative 3. Okay, I get plus 6i. I get minus 8i. And I get plus, because I'm doing negative 8 times negative 2, so plus 16i squared. Okay. So again, I'm going to combine my middle two terms. That looks like negative 2i, right? Positive 6 minus 8. And then again, I'm not going to write this one down this time, but this one is really minus 16, right? It's 16 times negative 1, that's minus 16. So if I do negative 3 minus 16, I'm going to get a negative 19, and that's going to go first, because we always put the real numbers first. Here's our answer for 6. Problem number 7, negative 7 plus I squared. Okay, so here's where we have to be careful with this one. This is not square 7 or negative 7 and square I, right? That's what a lot of people do. Very common mistake. That is not what we're doing for this problem, okay? The squared literally means multiply whatever's in the parentheses by itself, right? If I had 3 squared, I would turn that into 3 times 3, right? I would duplicate whatever is the base, right? So in this case, I'm going to do that. I'm going to say this really means negative 7 plus I times another negative 7 plus I, okay? So this is really the same thing as the last two that we just did, except it's disguised because of the squared. So if I multiply this out, I'm going to get 49. I'm going to get minus 7i, and I'm going to get another minus 7i, okay? And then I'm going to get I squared, right? Positive I squared, okay? So if I simplify now, negative 7 minus 7 is negative 14i. Notice how this did not show up if I just squared the stuff here, right? We kind of missed out on something, okay? And then 49, again, I squared is negative 1, so this is 49 plus negative 1, well, that's 48, okay? So there's your answer for I squared, or I'm sorry, negative 7 plus I squared, a complex number, okay? All right, problem number 8, another distribute. Okay, this one is a little bit strange. You might be kind of looking at this and saying, hey, it's kind of weird. It's the same problem. One's got a plus, one's got a minus, right? This is something we call the complex conjugate. The word conjugate just means give me a binomial and then switch the sign. So if I have 3 plus 5i, if I switch that operation from a plus sign to a minus sign, 3 minus 5i is the conjugate of 3 plus 5i. Okay, so this is a special set of numbers because watch what happens, right? I get my 9, okay, and I get a minus 15i, and then here I'm getting a plus 15i, okay, and that is not a coincidence. It's because we use the same numbers, right? And then I'm going to get a minus 25i squared. Okay, so if you notice, because these are conjugates, negative 15i plus 15i cancels. That is by design, right? We specifically make the numbers the same, but that middle value opposites so that I get a cancel happening right here in the middle, okay? So now all I'm left to do is take 9, and then remember 25i squared is, negative 25i squared is the same as negative 25 times negative 1. So this is really plus 25. So if I do 9 plus 25, I get 34, right? So there's no I left in this answer, which is something that we want a lot when we're dealing with fractions, right? We want to get rid of I, which we'll see in a couple problems, okay? But the idea here is that the middle cancels, but essentially it's just the same as all of our other binomial times binomial problems, okay? All right, moving on. Number 9. This one looks really complicated, right? So this is a problem where we're going to handle it in pieces, right? So I'm going to start off by looking at these first two terms, and if I think about my PEMDAS, we got to deal with exponents, we got to deal with multiplication, we got to deal with division if we had any. We don't have any in this problem, and then addition and subtraction is last, right? So if I'm seeing this exponent, let's handle that first, right? So I'm saying 3i quantity is squared. So remember what that means again. It means 3i times another 3i. Well, that's 9i squared. Well, I squared is really negative 1, so this is really negative 9, right? So I'm going to rewrite this part right here and say minus 2i. But instead of writing 3i squared, we just found out that that's really the same thing as negative 9. Okay? And then I'm just going to bring the rest down for right now. So I'm going to say this is 5 minus 2i and 2 plus 7i. Okay? So I just did my exponents. The next thing I have to do is all multiplication from left to right, right? So here's multiplication. These two are just like all of the examples that we just did, like the last 4, right? So I'm going to distribute and distribute. So it's going to become 10 plus 35i, okay, minus 4i, okay, minus 14i squared. Okay? And that looks like it's going to be 31i. And then again, remember, minus 14i squared is really going to become positive 14 because it's negative 14 times negative 1. So if I do 10 plus 14, I'm going to get a 24. So this is 24i. I'm sorry, 24 plus, because 31 was positive, 24 plus 35i. I'm going to put parentheses around this for right now. Okay, there's a minus sign. Okay. And then if I go back up here, this is the part we haven't done yet, right? We just kind of expanded out this thing and simplified it, right? We haven't done anything with this. So if I simplify this part, it's going to say 2i times negative 9. Well, that is negative 18i, okay? So now, if I wrap this up, now that I've done my multiplication, there was no division, now it's addition and subtraction, right? So I'm going to take this expression, 24 plus 31i, and from it, I'm going to subtract negative 18i. So minus, negative, well, hey, let's make that a plus, plus, okay? And now this really says 31i plus 18i, well, that's 49i. Okay, and then the 24 has nothing in this second term to change it, so I'm going to leave that alone. Okay, this looks like my final answer. Okay, so there's a lot involved with this problem. There was some exponents, there was some multiplication, some double distribute multiplication, some subtraction with negatives, right? So this is all skills that you know, but just be careful that you do them in the PEMDAS order and that you don't lose things like negative signs, which show up a lot with I. Okay, so good summary problem of everything we've seen so far. Okay, problem number 10. First time we're seeing a fraction. Okay, so let's talk about fractions. Okay, the issue with this, if I'm trying to simplify this, is I is not allowed to be in the denominator because we saw in Algebra 1 that you're not allowed to have something like a radical in the denominator, right? That's bad. And I is really just the square root of negative 1, right? So it's really a radical in the denominator, and our job is the same as what you learned in previous years, that you got to get that radical out of the denominator. Okay, we like denominators to be nice, whole, positive numbers if we can. So the way we're going to handle this problem is we're going to get rid of I by multiplying it by itself. Okay, and you might be saying, well, why am I multiplying it by itself? Well, if I do I times I, well, that's I squared, and hey, it's showing up again. If I squared is negative 1, no more I in the denominator, it's just a 1 now, right? So that's how we're fixing this, is by turning it into I squared. So here's what this becomes. 7I squared, right? And because I multiplied the bottom by I have to change the top as well. So this is negative 4I, okay? So this looks okay. Well, I squared is negative 1, so this really says 7 times negative 1. Well, that's negative 7 and negative 4i. Okay, so what I'm noticing is I have a negative on both the top and the bottom. They divide away, they cancel each other out. It's negative divided by negative. So my final answer is going to be 4i over 7, and that is my final answer. Okay, so the only thing I was trying to fix there was make sure the denominator is a nice, whole, positive number, and now I can say it is, right? All done. Okay, problem number 11. Same thing, right? Same thing as number 10. Got to get I out of the denominator, but here's the difference with this one is I'm seeing that my fraction 18 over 9, well, I can simplify 18 over 9. That's just a regular old fraction. So instead, before I start with the I stuff, let me just deal with the fraction. This is really a 2 over 1I, which I'm just going to write as I, right? So I simplified 18 over 9 to be 2 over 1, and now I'm just going to do what I've been doing. I'm going to say times I, okay? Top and bottom. So it's going to be a 2I on the top, an I squared on the bottom. Oh wait, there's I squared again. That's really negative 1. Okay, and now I can do 2 divided by negative 1. That divides nicely just like how 18 and 9 did. So I'm going to say the final answer to this one is just regular old negative 2I, no more fraction. Okay, so sometimes you can do this simplifying. If you didn't do it when you were doing this, you would just simplify at the end. You would get something like, negative 18. You would get 18I over 9, negative 9, and then you'd have to simplify that, right? Okay, so same idea, but just be careful. Okay, all right. Let me just check something there real quick. Okay, yep, that's good. Okay, all right. Problem number 12. Same exact thing. There is nothing new about this problem. I know the top looks a little bit more complex, right? But we're just going to distribute our I into both parts of that instead of just a single term. But I'm seeing the same thing that just happened in number 11, where when I looked at 11, 18 and 9 simplified, right? I had a fraction that I could simplify before I got started with the denominator. In number 12, I see there's an 8, a 4, and a 2. They are all divisible by 2, so the first thing I'm going to do is do that. I'm going to simplify the numbers and say if I divide them all by 2, I'm going to get a 4, I'm going to get a 2i, and I'm going to get a 1 on the bottom, which 1i I can just write as I, right? So I just simplified the fraction. Now I'm going to deal with the denominator. Here's my I over I, okay? And so if I distribute this I to both of these terms, I get 4i plus 2i squared over I squared, okay? These do not cancel, but they do both become negative 1. So if this one becomes negative 1, that's 2 times negative 1. Well, that's negative 2. This is a positive 4i, so I'm going to write plus 4i. Okay? And then the bottom one becomes I squared negative 1. Okay? So now I have kind of the same situation again. I can do some division. If I divide both of these terms, the -2 and the 4, by the -1, I'm going to end up with 2 minus 4i. And this is my final answer. Okay. Coming down the stretch, we're almost there. Okay, number 13. Okay, same thing again, right? I'm seeing I in the denominator. We got to fix that. But I'm also seeing a 5 that is in all three of these terms. So I'm going to divide that away. And I'm going to get over I, okay, by dividing the bottom by 5. And then I'm -7 minus 3i. Okay, so now I'm going to multiply by I over I. Okay, and I'm going to get -7i minus 3i squared all over I squared. Okay. Well, let's go through this piece by piece. Okay, I squared is -1, so that's going to make this a +3. So I have -7i plus 3, right, over I squared, which is -1, right? So again, let's divide all of this by -1. I will get +7i, okay, and I'm going to get a -3, and I'm going to make the decision to put that, okay, before the 7i, because that's the standard form. We always like the I to be last. Okay, so there's your answer for 13. Right, not a whole lot new, just making sure you can simplify your fractions. Okay, here we do get something new. Okay, this is the first time. If you take a look at number 13, I have 5i, which is just a single term. We call that a monomial, a single term expression. Now, number 14, I have 1 minus I, that is a binomial. This is what's called a complex number. Okay. The goal is still the same, though. Our job is to get I out of the denominator. Okay, so if I don't want I in the denominator, you'd think, based on what we've done previously, that I would just multiply by I, right? Here's what happens, though. If I distribute this I to the first term here, the I get minus I squared. But then when I distribute it to the 1, I get another I, okay? So if I were to simplify this, hopefully you're not writing this down because we're not going to do this, I get I plus 1, okay? When I multiplied the bottom by I, it didn't fix my problem. It changed the denominator for sure, but I still exists, right? So it looks like when I have a binomial like this, I can't just multiply by I, because even though I fix the second part, I kind of mess up the first part, right? So instead what I want to do, we have a new strategy. If I go all the way back, let's take a look at some of our previous problems. Let me see if I can find it, okay? I think it's this one, right? Here it is, okay? We have our conjugate, right? We had this situation where we had an expression, a binomial, and we multiplied it by the exact same thing, but we switched the sign. Our original one had a plus, the second one has a minus. When we did that, we had some canceling happening, and we ended up with a nice number that does not have I in it, right? That is our strategy for this problem here at the end, right? We're going to go to this one and say, okay, 1 minus I. If I multiply this by its conjugate, 1 plus I, okay, here's what I get. Okay, I'm going to multiply it all out. 1 times 1, well, that's 1. 1 times I, okay, that's I. Negative I, if I multiply negative I times 1. And then a negative I times a positive I is negative I squared. So this looks like I minus I, that cancels, okay, and here's what I'm left with. 1 minus negative 1. Well, that's 2. That's 1 plus 1. Okay, so if you notice, that fixes my problem. Now instead of having an I in the denominator, I just have this nice number 2. Nice, positive, simple number to divide by. Okay, so the only thing I have left to do now is, because I multiply the bottom by 1 plus I have to multiply the top as well. Okay, so this is just going to kind of carry along here and become 6I. Okay, and then 6I times I is 6I squared. Okay, and I squared is really -1, so this is going to become -6, okay? And then it's going to become a 6I plus 6I, okay? And there you go. We did it, right? We combined, okay? One last little thing to do here, though. We have to be careful. This is not a simplified fraction. I see 6 divided by 2 and 6 divided by 2. These all simplify by division of 2. So I'm going to do one more step and say this is -3 plus 3I. And technically it's over 1, but I don't need to write over 1s, right, in a fraction. So that's going to be my final answer. That is the most simplified final answer. Okay? All right, looks like we got 2 more. Okay, so we're going to just run through these ones and then we're done. Okay? So number 15 and number 16, I'll just kind of point out on both of them, nothing's going to be different, right, based on what we did on 15. Okay? Except that when we multiply the numerator, number 14 just has a single term 6i, and number 15 has a 2-term more complicated one, right? So when I do my multiplying of the numerator, it's just going to be a little bit more complicated, okay? So we're going to start off, we want to get 3 plus I to be a nice simple number, so I'm going to multiply by its conjugate, 3 minus I, okay? And so let's just deal with that first. Okay? You're going to end up getting 9 minus 3I plus 3I minus I squared. Okay, and that comes out to be, again, with my cancel, negative 3 and positive 3, 9 minus negative 1, which is 10. Okay, now I'm going to do the same thing on the top. I'm going to say multiply by the same 3 minus I, and now I have to distribute this one. 4 times 3 is 12. I get minus 4I. I get plus 30I minus 10I squared. Okay, if I multiply that out correctly. Okay, so here's what I get. This one, not canceling. Negative 4I plus 30I is plus 26I. Okay, and then I get 12. Negative 10 and negative 1 make a positive 10. So this is really 12 plus 10, 22. Okay, so this is my now simplified expression, but I have to look at my answer and say, look, 22, 26, and 10. They all have 2's in them again. So let's simplify that again. 11 plus 13I all over 5, right? Now none of these numbers have anything in common. This is a simplified fraction, okay? So that's 15. One more for practice. There's just a little bit of negative going on here. So here's the important point with this last one, right? The last thing to drive home here. When I write the conjugate of negative 1 minus 4I, I'm not going to change the sign of both parts. I'm only going to change this middle operation. This is a minus 4I, so I'm still going to use negative 1. I'm not changing that at all. I will make it then plus 4I. Okay, so be careful that you don't change both, or you'll see that I does not go away. Okay, so this is going to happen on the top and the bottom. Okay, so here's what I get in my denominator. All right, I'm going to get negative 1 times negative 1. Well, that's 1 minus 4I plus 4I, and then negative 16I squared. Okay, and that simplifies to, with my cancel, okay, 1 plus 16, so that's 17. Okay, and then in my numerator, I just have to multiply this out, right, to make sure that it all, kind of simplifies nice. So negative 5. Okay, it looks like I get plus 20I. I get plus 8I. Okay, and I get minus 32I squared. Okay. So now if I put together my i's, it looks like I get 28i, so plus 28i. Okay, and then again I got my I squared, turning this to positive 32. So negative 5 plus 32. That looks like it's going to be positive 27, right? Just by itself. Okay, and this is my final answer. 17 is a prime number, so it doesn't have anything in common with either of these. I can't simplify this one like the other ones did. Problem over, and it looks like we are all done. Okay, so that is the end of the complex numbers review. If you have any questions, you can post them in the comments below here, okay, and let me know.